Hello everyone, today I will talk about the recycling of the future. It's a concept which has a name. The name is closed loop, and in industry it can be defined as cradle to cradle, but cradle to cradle is a trademark. So you cannot label a product as cradle to cradle, otherwise you have problem with labeling and intellectual property. So if we consider the current industrial process, industrial product manufacturing and distribution and consumption, we have a linear system. First it starts with extraction. Then with extraction is the material is sent to factory which will refine it and which will produce the goods that we use and distribute it, and then throw in landfills in a huge garbage piles. Okay. This system is really linear in the sense that we don't have any cycle about this process. When we do extraction, what do? We usually extract petrol. We extract petrol to use energy, to produce energy, and to produce plastic as well. A lot of different plastic. We extract minerals. We extract different type of material which are further on refined and transformed. But this poses a lot of problems. First of all, it's very polluting. It uses a lot of water. And there is a risk of depletion because you extract, but at some point, okay, no more of this material, so you have to change the location. For example, in the US, we do fracking to get the fossil fuel, which a lot of impact on the environment, but it's not only on fracking, it's on many different material we extract that will create pollution. The other problem is that usually resources are not located at the same location, so you start to have like domination, like one country, 2, 3 countries will have the resource, and we start to have geopolitical problems. One big effect as well is what big impact on the planet is the transportation, because when you have to transport material from China, South America, I don't know where, Australia to the point of production, you have a lot of transportation and a lot of energy consumption. The manufacturing itself, when the manufacturing is in, let's say, developed country, a lot of regulation, that's okay, it's not so much pollution, but still. And garbage, it's a huge problem. Why? Because everything is mixed together. When there is separation of waste, usually either it's not done really well, or when it's separated at home location, sometimes put back together to be put in landfill. So this system is really animal-like. You take a monkey, you will take a banana, peel the banana, eat the banana, and throw the skin of the banana. Our industrial process is animal-like. It's really not evolved. We are very proud of our industry, but the process of our industry is really done. It's really not evolved. It's really like primitive, archaic. So now we'll see the alternative, the closed-loop system. How it is, what's the secret of this system, and why it will be the future of recycling. Okay, before to come this recycling of the future, let's see why this linear system paradigm doesn't give us the possibility to do recycling. Imagine you have this landfill of waste, and you think, okay, this is a resource that we could use and recycle. First to reduce these landfills, and second to reuse, so to get the value inherent to this garbage, this waste, to reinject it in an industrial process. And people start to think, okay, let's do that. it's just not working. Let's face the reality. It has been now years and years and years that people talk about recycling, and it doesn't happen. Why? First, because everything is mixed there, and when it's mountains of waste. So first you have to separate. It's very difficult because everything is mixed. Everything, you have plastic, organic matter, metal, different type of metal, different type of plastic, with different structure, etc. So the cost to do that recycling is huge, and no government, no company will invest in that. The only thing that can be done is maybe to identify some of the material and try to separate that, but I have no example of this being done. And usually when we talk about recycling, it's not really recycling, it's downcycling. It's what people do. They use that as a biomass and they burn it to produce energy for the industrial infrastructure. But it's really downcycling. It's not that we don't really use the value of these resources. We just burn it. It's so easy. So this linear system is just not adapted for recycling. It's just it produces at every steps of the way waste which has no value anymore. So now we'll see what can be the alternative, maybe with the closed loop. Okay, what is the closed loop paradigm? You may wonder why a guy who is doing permaculture is talking about industrial process, closed loop, cradle to cradle, because it's a paradigm which has been developed being inspired by nature. In nature, there is no waste. Everything that go out of a subsystem in nature, a tree, an animal, forest or whatever, all what is digested, all what is produced and fall on the floor and so on, everything is processed and reused by different type of organisms, and nothing is lost. Everything is recycled in nature. There is not one thing that nature will not use as a nutrient, as an habitat, as a resource. So permaculture is mimicking nature, and in the realm of agroecology, in agriculture, with the intent to have no waste and to work with nature, so to mimic nature and to have this cycle of recycling. Closed loop, that's the same idea, mimicking nature, but in the industrial process. So I think you guessed what the next point is, that instead of to have a linear process, we'll have a complete cycle. Okay. Okay. Let's start with the factory. The factory will do a product. This product will be distributed to customer, and at the end of the usage of this product, the usage cycle, this product will come back to the factory, maybe to be refined, transformed, disassembled, and go back to the production system. Why are we able to do that? Why is this system working? For the simple reason that this product here has been designed to be recycled. Okay? What does it mean? It means that a product which is modular, product which can be disassembled, and it's not so bound together that the cost to disassemble is so huge, so important that you prefer to throw it than to try to remove the different part and try to recycle different part. And the different elements, the different material which are used in this product, all of them are either you can recycle them to go back in the industrial process, or they are maybe organic parts which are not harmful, which are not toxic, that can be put back to nature and then recycled in the natural processes. So to be able to implement that kind of process, which is totally a recycling loop, is that you have to design the product in a way that the cost of doing the recycling will be lower than the cost of acquiring the materials for the factory. And this is just about design, okay? So the key, the secret, the key factor about being able to to implement this closed loop system is the design of the product. Today, the companies will be able to design a product which is what you can recycle. Then they will start to be able to distribute and communicate with the customer in a way that the customer will have incentive to bring back the product to the same, to the company which manufactures the product. And this is done usually with a discount. So you say, okay, you're a company, you manufacture a product, you say to the customer, listen, when your product is old, just get it back to us, and we'll give you a discount of 20, 30, maybe 40% on the cost of the new product, which is better, which has more functionality, which is the more modern product on the market. So this capability of recycling will be done through the design of a new product. So the design of new product will have to integrate the good feature. It has to be a valuable product, not something outdated, but something which is really responding to the need of the customer, but as well design in a way that it's easy to recycle, to get it back and dismantle, put apart the different components and the different material to be able to, for each component, to recycle it. So that's the secret of closed loop, is the design. You will see many videos on internet about closed loop, but no one is really putting the emphasis on the fact that it's about design. Imagine in the linear process, a car manufacturer will do a car, and they will do a painting on the car, on the body of the car, which is quasi impossible to remove from the metal. So what will happen at the end of usage cycle of the car is that it's going to the landfill, and the company doesn't want it anymore because it's too costly to remove just the painting, or it's too difficult to remove the different parts of the metal of the body of the car. But imagine a car which has been designed in a way that the painting has been chemically factored in a way that it can be easily removed from the metal. So if it has been designed this way, the cost and the automatization of this separation will be so low, so it will be really interesting to get back this car, to remove all the different parts, because it will be easy to do, it can be automatized, remove the painting, remove all different parts, different materials, and then you have a metal which is pure, okay? And then you don't depend on a foreign provider, you don't depend on a process of purification, which is use a lot of energy. You can directly reuse the metal. You have to know that in the car manufacturer today, if the old-fashioned way is that we just melt everything together with different metals. At the end, you have a steel, for example, which is not pure enough, not strong, which has not dynamic, the flexibility, the structure which is necessary for a new car, for the body of new car. So it is just used for another kind of utilization. So with this system, we can lower the cost of this recycling, and the price of this material, of the recycled material, will be lower than the price of new acquired material. And this more and more, because more the design will evolve, more it will be lower, economically interesting to do that, and more there will be depletion of the raw material, whatever it is, metal or whatever. So the cost of the raw material will start to really increase, and the cost of recycling will decrease, so it will be more and more interesting to do that. If after this first part of the presentation you are not convinced by the advantage of the closed loop system, of the closed loop process, the paradigm, circular paradigm, I think you have to consider the second part. The second part is extremely important because it's about market. How the circular paradigm, the closed loop, will impact the market, and how the companies, the product manufacturers, can take advantage of it. I will take an example. Imagine a company which produces fridge. Okay, they build the fridge, they distribute it to the customer, and then they have the ambition to be able to recycle 100% of this fridge. So what will they say? They will say to the customer, listen, if you buy our new fridge, and if you give back your old fridge from the same brand, we can give you 30%. And the new fridge will be much better, consume less, bigger capacity, have a lot of more features. Although the customer, usually people are kind of bound to an object. No, I don't want you touch my fridge is fantastic. But when after 2, 3, 4, 5 years, when the fridge starts to have a scratch, and when you see on the advertisement that there is a new fridge which do much better, then people say, okay, well, I don't want this fridge anymore. I'm not bound, I'm not attached to this fridge, I want the new version. So then you come and you say, okay, we will get back your old fridge. The old fridge will be recycled, and we will bring the new fridge. Usually you do at the same time. You deliver the new fridge at the same time you take the old one. Okay. In this process, what's happening is that you start to dematerialize the product. Why? Because okay, the fridge is moving like that, but it's coming back. Okay. So at the end, what the customer is buying? The customer is not buying anymore a fridge, because one day is a fridge, the next day is a new version of the fridge, another product. So you don't sell product anymore, you sell a service, okay? Because the material will be part of a loop which will be handled by the company, and the material belongs to the company, and the service is sold to the customer. So you are moving from a product-oriented market to a service-oriented market. And this has a huge advantage in terms of flexibility, and as well in terms of what we call cross-selling. Because when you sell a service, service is kind of immaterial, it's kind of it's quasi virtual. So what you can do is say, okay, I sell you this service, but I can sell you as this service, and you can have the upgrade, and you have the gold and the platinum, and or you want just the basic version, etc. So you are much more flexible on what you can sell, and you can add product, add service to the initial service that you sell. And this is very, very interesting for company. Imagine a restaurant, you sell fridge to the restaurant, you say, okay, I don't only sell you fridge, I sell you this this fridge service. But at the same time, for example, you are a restaurant and you're certainly interested in having continuity of service. You don't want your fridge to be down for more than 1 hour because all your you have in stock or you have in your cold storage will perish, and you don't want that. So we'll sell premium services, premium service, meaning that if you have a failure here, very quickly we are able to provide with a new fridge or even an upgrade, whatever. And this will be an additional services. So you don't sell only the basis, you sell as well the service of restaurant premium. You can sell a service of, you can put some Internet of Things, using Internet of Things to put some captors in the fridge. And for a restaurant, which is really, for whom is very sensitive, you will be able to identify maybe a failure in the different module of the fridge and maybe know before the customer that the fridge will have a problem. Okay, so it's kind of high maintenance service for the customer, etc. etc. The idea is you can have millions of examples. The idea is really that switching from the product to the service, you increase flexibility and you enlarge your portfolio, and you can really adapt to the customer expectation much more than if you just sell a product. Okay. This is huge for a company. Why is it so? Because when you sell a service, you can always adapt. You can always. It's difficult to adapt a product. It's better. It's easier to have a product with many functionalities that then you can adapt to the market, to the different demands, and then you adapt the price and, depending on the different features that the customer wants. So it's a huge market flexibility advantage. The second huge advantage is fidelization. Why? It's obvious because when you sell a fridge and the customer having this incentive to lower the price of your new fridge of 30–40%, of course he will buy the same brand. Of course he will buy the new version, the new enhanced version of the previous fridge. So you keep the customer. You start to do fidelization. Your customer is part of this closed loop. This way you do not face the problem of acquiring new customer. You have to know that in the market, when you want to acquire a new customer, it's a lot of investment. It's very costly to acquire a new customer. And if you succeed in keeping your customer, then you will not have this issue of penetrating a new market, penetrating new type of customer with a new product, new service, etc. So the fidelization is kind of permanent resources, and it goes well with the idea of the cycle. No? It's a permanence. Okay. In terms of fidelization, if this is not enough to economically bond your customer to your brand, the customer to your brand, is as well the type of fidelization you will do. Nowadays, what was for the last 20 years, what was hype was what we call customer-centric. Okay, the customer is at the center of everything. We love the customer has all the right, and we will do everything that we can for the customer. The issue with this approach is that it's increased the narcissistic feeling of the customer. And you can imagine that a customer is maybe not fed up to be in the center of everything, but doesn't find any really value. It's a bit sterile, it's a bit too much narcissistic. So you don't give really additional value, something you don't feed the customer, you don't giving something, you're just giving a service, making him more powerful, more, with more comfort. But when if you communicate being a company which care about the environment, you totally change the focus. It's not anymore about the customer is the most beautiful person in the world. Is that what is the most perfect world is more like an ecosystem that we try to protect, and we require the help of the customer in this objective to protect the environment. And then you don't give only the value of the service to the customer, the product to the customer. You give the value of ethic. You say to the customer, okay, if you are a partner to protect the environment by not having any waste, by reducing the energy usage, you will be with us to make a better environment. And then you start to create a real strong partnership with the customer, because the customer will be rewarded by ethic, by a common goal, common moral, common objective, which is to take care of the environment. So you let's say that you complement this economical loop of recycling by a semantic factor to do fidelization of the customer. And if you succeed in these two factor implementation, then you are sure that your customer will be really a fidel customer, and really to have a very robust and resilient cycle. The last market advantage is more in terms of infrastructure and logistics. When you have this kind of system, because you don't depend anymore of external resources to feed your system, or maybe just a bit, because you will still need maybe to increase the sale and to have more material. But you are autonomous, and usually what you do, if you are autonomous like that, you can shrink your model, and you can become local. You can, instead of to have one huge battery factory there and there and there, you distribute your factories, and you will be able to have this flexibility and autonomy on local scales. It can be regional, it can be national, but you will have this resilience which is local, and so you will decrease the cost of logistics. And by being more local as well, you will develop a local culture. You will be more adaptive to the local context. So the next century will be really about design. We see that the condition to succeed in this model is about design, and more we go in customization. So design is customized. So you can imagine that a factory in a certain part of the world has really different design than other factory in different parts of the world. So when you go local, we'll be able to adapt in a better way to this local condition, local culture, and local constraint as well, obligations. And the raw material will be the same, but the design can fluctuate. So if you are already in this move for a better design, then you will go to the customized design, and you will adapt not only to the customer, but as well to the context of the customer, because the customer will always want a service which is adapted to the context where the customer is living. Okay, so being local is really as well both a logistic value addition, but as well a cultural value addition. I did a list of the advantages of this solution compared to the linear system. First key factor is energy saving. When we reduce in a magnitude factor the extraction process, because we don't need so much material because we recycle the material, then we will save a lot of energy. We'll save energy for the transportation because we will become local, and we will save energy, a lot of energy, in the transformation process of the material, refinement, chemical transformation, melting, etc. So that's an important point. Another point is the material saving. Of course, that's the idea of the process is that we reuse the material and do not throw it away, taking raw material from the earth. So this will be a big, an important factor, and we can imagine that considering the growing population on Earth, considering that now the middle class of the third world, I mean the developing country, will reach a point, an ambition of economic level and comfort equal or similar to what we experience in US and Europe, where the consumption, the ratio show that we use 5 times the planet just for our consumption. We can imagine that if we have 7 billion of people, even more in the future, who have the same level of comfort than our Western world, that the planet will not be able to stand that. So this system will be a system which will resolve in a huge proportion this problematic. We can even imagine that if we have here a neurotic consumption, as we have usually in our consumption system, this closed-loop system will allow to control the depletion of resources and the pollution and the consumption of energy. So I would even say that away from this system, from this closed-loop system, there is no future for us because the planet cannot sustain this growing population with this ambition of comfort and product usage. Of course, we will reduce pollution because there will be no waste anymore. Stopping extraction will reduce pollution, etc. At every step of the linear process, we have a lot of pollution, and with this system, we control pollution. A very important point is about market competition, competitivity. Until now, ecology and environment protection has been always seen as an effort of regulation, controlling companies, controlling people, make sure that companies will not will have a good infrastructure, do not pollute, etc., etc. And every time it's about constraints. It's about adding cost to the companies, which often feel frustrated because they see it really as an obligation, and try to push for the minimum always on that direction. But with that competitive advantage we saw, like transformation of product to service, fidelization, what we saw in the previous part of the presentation, this system could become a competitive advantage, and that makes the difference, because once the leaders will implement the system and will really gain in terms of market share, you can imagine that everybody will try to follow and to duplicate the same model. And that's which will certainly make the difference. One important technology which very, let's say, concomitant, or let's say has a lot of interaction or similarities with the closed-loop system is the 3D printing. 3D printing is a technology which first reduce the consumption of material, because you don't make a piece and extract the part which has to be removed to make the final piece. No, 3D printing use only the exact quantity of material necessary for doing the piece, so there is no waste. Okay, that's first thing. Second thing is that we see that with 3D printing, at the same time that we see 3D printing happening on the market, appears as well recycling machine, because the material for 3D printing can be a bit expensive. So it's always interesting to be able to reuse the object which has been done with 3D printing, and to re-inject them in the process of 3D printing. So we are on that philosophy of closed loop. And more than that, by making our closed loop more local, you can imagine that it goes the same way. You have the design is flowing on internet. There will be a sharing of design, customization of design based on local constraint, and local production. So when I talk about 3D printing, it's not the small 3D printer we have home to make some gadget. I'm talking about 3D printing which can deal with metal, with glass, with strong polymers, etc. So we can imagine, I mean, big 3D printing infrastructure. We can imagine to have 3D printing infrastructure in this factory, and really a system of recycling based on a 3D printing tool company infrastructure. As well, 3D printing is by this architecture, the architectural product it produces is the modularity and the imbrication. So it can ease as well the assembling and the disassembling of the product. Finally, an example to show that once the company will shift to this model, that this model has is a very strong structure, a strong framework to develop ideas. I will talk about paper. How do you want to recycle paper in this system? Assuming that the problem with paper is that you cannot recycle paper indefinitely. The problem is that paper has fibers, and when you recycle, you will shorten every time the fibers of the paper. So you recycle once, twice, etc. But at some point you cannot recycle anymore because the paper will not hold together because the fibers are too small. So how to resolve that problem in a total recycling loop? There was a company who resolved the issue, and this company will shift from the product to the service, proposing to the customer not anymore to sell paper, but to sell a service of printing. So what did they do? Their customer are companies which use a lot of paper. So they provide with the machine, the printers, they provide with the ink, and they provide with the paper. You have to know that the problem in recycling paper is that the ink, to remove the ink from the paper, is a chemical process which is very impacting because it uses very damaging chemicals, sulfur and other chemicals. So you could even consider that it's for the impact on the environment, it's better to produce paper from trees than to recycle paper because the whitening process is very damaging. So what did they do? They gave to the company, the customer company, ink in the printers, which is an ink which is easy to remove. So they bring the paper, the printer, the ink, and they will get back the document which has been produced, the used paper, and they will recycle it and bring back to the company. And they will, at some point, what will happen is that, okay, they will get back this paper. At some point, they cannot recycle it anymore because the fibers are too thin. So what did they do? Actually, when the number of cycles is too high, they just reuse this paper as a biomass, which will be re-injected in the factory as a source of energy. So they will burn the biomass to produce energy to run the factory. So that's to illustrate the fact that if you stick to this model and if you try to put to invest and invest in money and intellectually in engineering in this process, we will find solution, and it can go very quick before people really implement this system. So it's just a matter of putting our energy and putting our thinking in this paradigm.